So we're going to begin today with a review of yesterday's types of questions where we had compound inequalities, particularly with the word and or, and you're going to solve both of them, and you're going to have the word and between it, and then you got to think about the graph with regards to the word and. That way you could present your final answer. Okay, so I'm going to pause it right now, copy it down, solve it, and then we'll talk about it. So it's pretty simple. You just solve this one, and then solve that one, and then think of both answers with the word and between it. Let's begin with the one on the left. To get rid of that plus one, you're going to do a minus one. And of course, what you do to one side, you do to the other side. You're going to end up with x is less than 3, okay? And then on the other one, we're going to get rid of the the minus 2 by doing a plus 2. And what you do to one side, bless you, you do to the other side, plus 2. Then you're going to have the inequality negative x is less than 8. And for your final step, you're going to have to divide, because what this really says is negative 1 times x, right? Negative 1 times x. So you're going to get rid of that multiplication of negative 1 by dividing by negative 1 or dividing by negative 1. Technically, you could have also multiplied by negative 1 and multiplied by negative 1. You'll get to the same answer anyway. Because this is our last step and we are multiplying or dividing by negative 1, we are going to be flipping this inequality, and it's going to become a greater than symbol. So x is greater than negative 8. So some of us, as I walked around quickly, I saw that we had these answers, and some of us put this answer with the word and then put x is greater than negative 8 right next to it, and we wrote this as an answer. But technically, you can't conclude that this is the answer until you write it on a number line, okay? Now, if the areas are together, then yes, the word and makes sense, but you should write it as a compound inequality written together with the x in the middle, smaller number on the left side, bigger number on the right side. However, let's take a look at the graph before we even think of those different situations. What we have here is x is less than 3, and also x is greater than negative 8. So on a number line, obviously the negative numbers are on the left side, negative 8. The positive numbers are on the right side, positive 3. And when we think of x is less than 3, less than is to the left, and greater than is to the right. So right here, x is less than 3, less than's to the left. And over here, x is greater than negative 8, greater than is to the right. Because this is an area that's together, we have to write it as a compound inequality written together. And that's really easy to do because we already have the numbers organized according to the number line, the smaller numbers on the left, the bigger numbers on the right. All you have to do is put an x right between the two numbers, and you always put less than symbols. Why is that? Because if the smaller numbers on the left and the bigger numbers on the right, they have to open up to the right always, okay? And this is what you would put as your final answer, right here. Negative 8 is less than x is less than 3. Do we get it? Okay, let's move on to another. Everybody copy that one down. I want to pause it, and then we'll solve it. So once again, we're going to do these two problems separately and then consider the word and between them, see if the areas truly are together. On the left one, we're going to get rid of the minus 5 first by adding 5, and what you do to one side, you do to the other side. You're going to end up with negative 3x. The inequality comes down. 1 plus 5 is 6. And what this really says is negative 3 times x is less than 6. So you don't want the multiplication of negative 3, so you do the opposite. Divide by negative 3, divide by negative 3. And you will end up with x, and you have to flip the inequality because you divide it by a negative. Whenever you multiply or divide by a negative, you have to flip that inequality. So that less than becomes a greater than, and that is a negative 2. Okay, so we have x is greater than negative 2 as one of the answers. The other one, we're going to solve it just the same. We're going to get rid of that minus 1 by doing the opposite, plus 1. What you do to one side, you do to the other side. You're going to rewrite it. 2x is greater than 2. That's really saying 2 times x is greater than 2. So we're going to do the opposite of multiplying, which is divide by 2, divide by 2. That gives you x. You do not flip the symbol because you didn't divide by a negative. That's just x is greater than 1, okay? So we have those two answers with the word and between it, and we must consider it or look at it on a number line to determine if we're actually going to write these together as a compound inequality with x in the middle and the smaller number on the left side and the bigger number on the right side. So let's go to a number line. The smaller number is -2. Any negative number is definitely smaller than a positive number. +1 is over here on the right side. And when we look at this guy, it says x is greater than -2. Open dot at -2, greater than is to the right. And this one, x is greater than 1. Open dot at 1, greater than is also to the right. Okay? So they're both pointing in the same direction. This is like one of those special cases we were talking about yesterday. And we have to really consider this word and. Okay? So yesterday we did that little activity where I said if you have blue jeans, stand up. If you have white shoes, stand up. If you have blue jeans or white shoes, either one or the other, you could stand up. But when we use the word and, if you have blue jeans and white shoes, there has to be both. It has to be overlap, right? So if we're considering this answer red and this answer blue, and there's 3 parts to every compound inequality on a number line, here's one part. Is there a red or a blue line on the left side? Is there a red and a blue line on the left side? No, right? So we're talking about the word and. So is there, right here in the middle, is there a red and a blue? No. Is there over here a red and a blue? Yes. So the only part that satisfies the word and would be over here from 1 this way. So the only answer that you type in on the test this Thursday is x is greater than 1. That's the only thing you type in. You do not type in x is greater than -2. Okay, that would be incorrect. Okay, you only type in x is greater than 1. I hope that makes sense. Okay. It's like if the red line were the white shoes and the blue line were the blue jeans. Do you have both white shoes and blue jeans here? No. Right here, both white shoes and blue jeans, right? Overlap is what matters with the word and. Let's try another. Copy that one down, please. And once again, we have 2 separate inequalities with the word or between them. Not and this time, it's or this time. You're going to solve the left one, solve the right one. Think of both answers with the word or between it on a number line. That way you'll know what to actually put as your final answer. So we're going to distribute first. -2 times x is -2x. -2 times -1 is +2. Then we're going to rewrite it, bring down the greater than, bring down the 5. Now we want to get x by itself on the left side of this inequality. So here's x. You want to get rid of the -2 and the +2. You begin with the +2, right? How do you get rid of something? You do the opposite. The opposite of +2 is -2. What you do to one side, you must do to the other side. Here's your new inequality, -2x. Bring down the inequality, greater than 3, okay? After that, you need to realize that you have -2 times x is greater than 3. So you're going to get rid of that multiplication, this multiplication with division. Divide by -2, divide by -2, and you will get x. Don't forget to flip the inequality symbol. This greater than has to become less than because you divided by a negative. And you have 3 divided by -2, and a lot of people freak out. Oh, I can't do that. So what? It's just a decimal, right? What is 3 divided by -2? It's technically -1.5, okay? So x is less than -1.5 is one answer. Let's go for the other. Now, the other's kind of weird because you have x on the right side instead of the left side. We could solve it on the right side and then flip the whole thing over. That's what I'm going to do. But you could solve it other ways as well. I want to get rid of that 7 first by subtracting 7 and subtracting 7. We will have -2 is less than -x, okay? So if I want to change this -x to a positive x, I could either divide both sides by -1 or multiply both sides by -1. I am going to multiply both sides by -1 because the other time I divided by -1. Anyway, when you multiply or divide by a negative on your last step, you have to flip that inequality symbol. So this guy is going to change to a greater than. And the -x obviously is going to become a positive x. That was the whole purpose of multiplying by -1. And over here, the -1 times -2, that becomes +2. Okay, so we have 2 is greater than x, but we don't want to talk about 2. You don't want to talk about 2 saying 2 is greater than x. You want to talk about x. X is less than 2 because 2 is greater than x. So let's flip it around and say that x is less than 2. It'll make it a little nicer to graph. So we have those 2 answers with the word or right between them. But the question is that how I present my answer? I won't know until I look at a number line and think of the areas of these inequalities, okay? So let's do it on a number line. You have the smaller number on the left side, which happens to be the negative number, negative 1.5, negative 1.5. And you have the positive number on the right side, because it's greater, 2. Let's graph the negative 1.5 inequality with the red. So x is less than negative 1.5. So that's an open dot. Less than is to the left. And the other one I want to graph in blue, x is less than 2. Open dot at 2, less than is also to the left. Okay. Now, we really have to focus in on the word or. Okay. Once again, with any compound inequality graphed on a number line, you have 3 parts to it. You have the left part, the middle part, and the right part. Looking at the right part, is there a red or a blue on the right part? No. Looking at the middle part, is there a red or a blue right here in the middle part? Yes, there's a blue, right? And or does not mean both. And means both, or just means one or the other. Make sense? So what is my answer going to be? It's going to be from 2 to the left. Okay, so x is less than 2 is my only answer. So the answer is x is less than 2. Okay, that's the only answer that you type in for full credit. Okay. Once again, the logic is or. Like if I said, if you have white shoes or blue jeans, stand up. You don't have to have both. As long as you have white shoes or blue jeans, you're able to stand up. So over here, you don't have neither red nor blue. Right here, you have blue. It satisfies the blue or red. And over here, it's blue or red. It's actually both. So from here this way, it starts satisfying the or, right? That it's one or the other. What do you think? You get it? All right. And one more here. This one is a hypothetical situation. Pretend you have 2 inequalities to solve with the word and between them. And you get the following answers. You get x is greater than 1 and x is less than negative 2. What would your final answer be? I want to pause it, talk to a partner, and then I'll ask somebody to explain. So to make it a little easier for you, I put these multiple choice options. You know what? Let me do one more here. Option E, none of these. Okay. So anybody have an idea what the answer is? A, both of them, right? Maybe? I don't know. Did you graph it? You can't make sense of the answer until you actually visualize it, right? So let's graph it. So everybody, if you haven't graphed it, please graph it. Here's a number line. Put the smaller number on the left side, the negative 2. Put the bigger number on the right side, the positive 1. It says x is less than negative 2. Less than is to the left. And the other one says x is greater than 1. Greater than is to the right. Okay? And we really have to focus in on the word and. Okay? What does and mean? Both, together, overlapping, right? So there's 3 parts to a number line. Do you have both the blue and the red over here? Do you have both blue and the red over here? Do you have both blue and red over here? So in what situation will you have both this one and this one together? Never. So what does that mean? That means no solution. I mean, if this were the multiple choice question, it would be E, none of these. But the real answer is that there's no answer. The word and implies no solution. Okay? Do you get it? Yes? And here's another tricky one, very similar to this one. What if I had, let's go with x is greater than negative 1 or x is less than 2. Okay? If you had this, a lot of people are going to think, like when you graph this guy, here's a negative 1, greater than is to the right, okay? And over here is positive 2. And I'm going to graph this one in blue, less than's to the left. A lot of people are going to think, oh, the areas are together, so I have to write it as a compound inequality with the -1, with the 2, with the less than symbols, and they write this, and it's going to be wrong. What the heck? Why is it wrong? Because of the word or, okay? This is a really special case. Because if it's one or the other, then technically the red one keeps going this way and the blue one keeps going this way. And there's 3 parts to every compound inequality answer on a number line. On the left part, do you have a blue or a red? Yes. You have a blue or red? Yeah, you have both. You have blue or red? Yeah, you have red. So the whole thing satisfies the word or, which would mean all real numbers. So right here it would be x equals all real numbers, or infinitely many solutions, right? I don't think I'll give you one of those on the test, but it's good to know. All right, so let's jump to the actual lesson today. Today, like on the worksheet, they gave us a compound inequality graph, and we need to be able to write the absolute value equation that produces that graph, or the absolute value inequality that produces that graph. So to write an absolute value inequality, you need to have these notes in your head memorized. It's the absolute value of x minus the midpoint. Everybody should know what a midpoint is. It's simply the point in the middle, equals, and the number over here is going to be the distance from the point to the midpoint. Okay, so I'm going to pause it right here. I would like you guys to copy this down right here. And just keep in mind that this is a number, the midpoint, and then this is also a number, the distance from one of the points to the midpoint. Okay, so your final equation is going to look like the absolute value x minus 3 equals 2. That could be absolute value equation. So I'm going to pause it, copy that down, and then we'll go for this first graph, the example here, and we're going to use these notes to produce that equation or that inequality. Now, the thing is, when we're talking about an area, it's not just the equal sign, it's an inequality. And we're going to fall back on prior knowledge to help us remember this. Instead of an equal sign, you need an inequality. If the areas are apart, that's annoying. If the areas are apart, that means that it's going to the left or to the right. So you should think of the word or if the areas are apart, okay? So if the areas are apart, use greater. And I misspelled greater, just so you could remember that if the areas are apart, you're using the greater than symbol. If the areas are together, then you're going to use the less than symbol. Okay, so once again, if the areas are apart, it's going to the left or to the right, use greater than symbol. If the areas are between here and here, like on this one, you're going to use a less than symbol, okay? So with this said, let's write the absolute value inequality that represents this example right here, okay? So let's begin by identifying the midpoint. What's a midpoint, anybody? -3 is the correct midpoint. So this is the midpoint. That -3 is going to go right in here. So let's begin by writing absolute value of x minus the midpoint. What is a midpoint? You guys just said -3. And it's important that if it is a negative, you include that negative, because that minus sign is going to eventually change that negative to a positive, right? But then we have the equal sign, and then we have the distance from a point to the midpoint. Which point? Any point you want, right? So I'm going to go with the -5. What's the distance from -5 to 3 to -3? 2. Okay, so you just put a 2 right here. Whoops. And we're technically done. The only thing that we could do to make this look a little bit nicer is to change the minus minus to plus plus. So the absolute value of x plus 3 is equal to 2. I'm sorry, I shouldn't have used equal. Are these areas apart, going that way, or are they between here and here? Obviously between here and here, which means that we're going to be using what kind of symbol? Less than symbol. Less than symbol. Okay. Now, one more thing. They are solid dots, so I do need a solid line underneath that inequality. So the absolute value of x plus 3 is less than or equal to positive 2 is the final absolute value inequality that will produce that graph above with two solid dots at -5 and at -1 with an area that's together. If you were to actually solve this, it's already isolated. By doing the positive and negative situations, getting answers, plotting them on a graph, you would get this graph right here. Okay. So this final section is really easy. All you have to do is recognize the midpoint, put it right here, x minus whatever that number is, and then equals the distance from one of the points to the midpoint. Doesn't matter which one, it'll be the same distance. So on Google Classroom, you will have a picture of these questions straight from our textbook. okay? And you could just look at these and work on each of these. So go ahead and pick one. Which one would you like me to do? Just as another example right here, pick one. 26. Let's take a look at 26 here. All right, so we said that we're going to write our inequality as the absolute value of x minus the midpoint. I want to put MP right here just to remind us that that's a midpoint. And then is this area together or apart? Apart, and if they're apart going to the left or to the right, that means we're going to be using what kind of inequality? The greater than symbol, right? The greater than symbol, okay? What is the midpoint? Might as well write that. The midpoint happens to be 1 right here. The two dots, the perfect point in the middle is 1. So the midpoint is 1. And the distance from the point to the midpoint is from here to here is 2 units. So 1, 2. Or if you want this way, 1, 2. It's still 2 units. So there's my answer. The absolute value of x minus 1, close absolute value, is greater than 2. Piece of cake. Yay? Once you memorize the formula, it's a piece of cake. Once you know that it's x minus the midpoint, close absolute value is greater than the distance from the point to the midpoint. It's really easy to write that. There will be a couple of these questions on Thursday's test, and that concludes pretty much everything that we need to learn for the test. Is there a different one you guys would like to try? Or are you guys good? Yes. 27. All right. 27. Okay, so let's first find the midpoint. So if you go 1 unit this way, 1 unit that way, 2 units, 2 units. So the midpoint is going to be right here, right in between, right? So think about a number that's perfectly between 0 and 4. That would be the number 2, correct? So the midpoint's 2. So we're going to be able to now write the absolute value of x minus that midpoint 2. And since the areas are apart, it's going to be a greater than symbol, greater than. And they are solid dots, so you're going to have a solid line underneath that inequality. And the distance from the point to the midpoint, you just got to count it, right? So remember, these are going by 4, right? From right here to here, it's 4 units. So 4 units, another 4 units, it's 8, plus another 2 is 10. So you'd have a 10 right here. And there's your actual absolute value inequality that'll produce this graph with 2 solid dots going that way or that way.